Hello and good day everyone. We are from Group 4 Section 1 are going to present about our IDP project titled Smart Traffic Light. Our group consists of 4 team members, which is MJIIT IDP, Muhammad Basir bin Faris, me, Muhammad Zulkarnain bin Kamis, and Teo Kang Wen. For the background of the study, basically we focus on the history of the traffic light and some of the circumstances that led to its construction, which is from incident that happened to the officer in London in 1868, when the first traffic light were exploded and killed the police officer, as well as some of the people that were involved in its original conception, which is Officer William L. Potts of Detroit, Michigan in 1918. That's the original concept been patented by Garrett Morgan of Cleveland, Ohio, to be secured by United States patents for traffic signal. Then we evidence traffic lights control systems that commonly used nowadays. It's stated from article history.com about the first electric traffic signal installed. For the available commercial product, we cover also in the literature review. Basically, we refer to the traffic light system that already exists in the marketplace, which is Smart Traffic System Controller, SNAR traffic systems. Based on the demonstration building of the Smart Traffic System, we found that the company Malaysia's Smart Traffic System Controller, SNAR, will be collaborating with Alibaba Cloud to build a smart traffic management system in Malaysia. Stated from article The Star, they focus on the use of cloud computing resources and talent development program of Alibaba Cloud in order to make a more effective traffic light and several key features. From that, we came up with the concept of using a Raspberry Pi, Arduino Maker, and transmitter receiver to tackle one of the issues we have discovered, that is to aid the emergency vehicle such as ambulance, fire truck reaching destination without the waste of time. That's the problem statement. We focus on the inefficient traffic light cause many possible problems, and this method requires a solution to each of these problems with some statement from several research. The first problem statement is stated by Subankar Gautam. The traffic congestion in the urban area never meets an effective solution. The second one, stated by Muhammad Farhan Shah. This method also involves life against involving the use of emergency vehicles. Emergency vehicles face difficulties passing through the congested highway as some vehicles tend to take over the emergency lane. And for the project significant, we focus on the road congestion that happened in Malaysia, especially Kuala Lumpur. It has been reported that the issues of traffic congestion has occurred since the 1970s, and this issue lasted until the 21st century. Hardy and Sarifa stated that users' comfort on the road and traffic congestion in the city are global issues. So in this project, we propose a system consisted of Raspberry Pi and Arduino that aims to improve the traffic efficiency, also to provide least congested roads for the emergency services. For the NAVC, the needs of our project basically for the traffic congestion always trapped during the office hour or peak time. Ambulance, fire engine, and police car trapped inside the traffic. The approach of our project basically we use the Raspberry Pi to communicate with police station, hospital, and fire station. Also, it can capture the real-time situation, for example, traffic congestion, hence analyzing. Also, the use of AI detection, emergency vehicle from distance, and controlling traffic light system to signal other vehicles to make way. The benefit from our project basically is to minimize time travel on road, and the emergency vehicles can complete rescue operations with higher efficiency. The competition from our project basically nowadays, traffic light system is improving fast for past few years. Also, few companies have begun to focus on smart traffic camera association with traffic light. And the last one, some street in Malaysia had deployed smart traffic light system. Okay, that's all for me. I will pass the presentation to Teo Kang Wen to explain about the product specification, cost estimation, project limitation, and the future works. Thank you.
Alright, thank you, Zul. Now is the right time to introduce some of the pieces we use in this project. There's a list of components, but I'll just present the important components. Well, since we had the plan on vehicle detection from camera, we need a sustainable yet budget-fitting microprocessor. Considering all choices available, we have clicked in the latest piece of tech, which is a Raspberry Pi 4 Model B. This piece of tech contains a lot of powerful features, including Ethernet, camera port, and also it is SD card availability. And the most important that it is compatible with Arduino. Next is the second component that is responsible for a whole feature, Arduino Mega 2560. For a size of 100 x 50 mm, this piece of tech can hold 54 digital and 16 analog I/O, which is very enough for a complete traffic system. The other reason we chose Arduino 2560 is because of the great Arduino family. The size of Arduino family provides unlimited possibilities for our project. In addition to this project, we selected another piece of tech from the Arduino family, which is the RF315 transmitter receiver. Now, I'd like to pass the presentation to Eng Kai. Thank you.
Now it's my turn to show our project demo. In this project, I tested 3 videos. The first video is here, and next two video I will show in later. Okay, as you can see there, the two cars inside the bounding box, when you passing through the green line, you will increase the total number of cars. But actually is that each car has only one bounding force. It cannot two cars together in one bounding force. So this in our future we will need to improve this. And the green lane I can set everywhere. If it depends on the road condition. If the camera is in the middle, so I set it here, or I can set it further or nearer. But the nearer to the camera is better because it can accurate counting the number of cars. Okay, for the second video, okay, as you can see that when the red dot passing through the green line, it will increase the total number of cars. So this is our in my second video. This is my third video. Okay, as it is a similar condition to the first video because the two cars are in the same boundary box. Actually, it must in different boundary box. Also, if the camera is the location of the camera need to be set. Actually, is on the middle of the road and have the L-shaped traffic light, and the CCTV camera is looking down here the road, so it's better to count the total number of cars because if the camera is just like this vision, the two cars will considering inside a one bounding box. The accuracy of the bounding box in this project is not very accurate. This project we have tested three videos. The first video accuracy is much lower than the others two, but the third video accuracy is much higher because the camera is captured in the middle of the lane, so it can count the number of cars left and right accurately. I would like to pass to Nick to show the project demo for the Arduino part.
Hi, this is Nick speaking. So currently I'm showing you the full connection of our system. So this middle part is the Arduino Mega and it's connected to this sets of LED. So this LED will be our output for the traffic light system. Also, this part is the receiver of our RF module. So this receiver will receive the signal from this transmitter that's connected to this set of Arduino Nano. So this Arduino Nano is actually will be inside the moving emergency vehicle. So that means when this set of Arduino Mega and transmitter approaching this Arduino Mega, meaning that it's approaching the traffic light, the receiver will detect the transmitter from detect the signal from this transmitter, and it will turn on to the emergency vehicle mode that I will then explain later. So, and this part is our Raspberry Pi that's connected to the camera module, and this camera module will detect how congested our lanes are. Actually, real life system, we will have 4 cameras that will each detect the single lane. And this Raspberry Pi will directly connect that to our Arduino Mega and to send the signal how congested each lanes are. Then I will proceed to the next part, my explanation that is about the lane congested mode. So actually, since our Arduino Mega and our Raspberry Pi is not the same person due to the COVID situation, we need to do it separately and we can't seem to get it together. So one of our solution is just to manually trigger the pin that is connected to the Arduino Mega. So actually this, I will then trigger a pin. As you can see, I connect a single wire to a certain pin to trigger what mode I wanted and which lane I want it to be congested. And this signal is supposed to be sent from the Raspberry Pi to the Arduino. But since our Raspberry Pi is not together with me, I will just trigger it manually. As you can see, what I just connected is I said that this lane, this set of traffic light will be congested. So when this traffic light is when this traffic light turns green, it will be longer compared to others. So for the other part of the traffic light, it will maintain as normal, meaning that the time won't change. You can see it's still normal. And when it comes to this lane, it will be longer and it's in the lane congested mode, meaning that this green light will be turned on longer to let other car pass through it longer than other lane. So when the lane empty mode, I triggered another pin that said that this lane is empty. So meaning that no car is on the lane currently. So when I trigger that switch, this green light will be shorter compared to others. So as you can observe, after this, and the green light is very short. So for the emergency vehicle mode, device that we're going to use is this transmitter and receiver as I explained before. So when I complete the circuit, meaning that I turn on this transmitter, the transmitter will send a signal to this receiver, and when the receiver receives that signal, it will turn into emergency vehicle mode. So since this transmitter is connected to this set of traffic light, meaning that assume that there's emergency vehicle on this traffic light link. So it will maintain as a green light until I disconnect the transmitter again. And there's no signal, but will be in this mode for quite some times, around 2 to 3 seconds because if we change the traffic light promptly, collision with other lane might happen. So that's why we have that delay a little bit, and the traffic light will be on normal mode again. So, see. And that's all from me. I will pass to Tiokawan to further explain the other part. Thank you.
All right, thank you, Nick. So now I'd like to present on the cost estimation for our project. So table on the right can show the price for every single components and the rent total for our project. So going down the table, starting from the Raspberry Pi 4 that costs around 250 ringgit, and followed by Arduino Mega that costs around 34 ringgit, and followed by the Raspberry Pi 8 megapixel camera that costs above 100. Notice that RF315 that costs only 5 ringgit that actually plays a very important role in this project. And the last but not least is the micro SD card of 64 GB that costs around 30 ringgit that supports the Raspberry Pi 4 Model B. So the rent total for our project is around 533 ringgit. So next, this is a pie chart for showing the package of every component. So the champion must be the Raspberry Pi 4 Model B that takes around 65.5% of the grand total, and followed by the second expensive component, which is the Raspberry Pi 8 megapixel camera, and the third component that takes around 6.4% of the grand total is the Arduino Mega 2560. So moving on to the next slide, here I'll talk about few limitations on our project. The first limitation was held within the hardware RF315 transmitter receiver. Our expectation on the functionality of this component is to enable the engagement between the emergency vehicle and the traffic light system. However, the receiver of RF315 can only be paired with the transmitter that we register together with. So the second limitation will be our national lockdown that causes us to change our initial plan to combine two components together. However, there are still hopes and spaces of improvement for this project. Since we are limited by few factors, we have accepted the fact to pass the legacy to the next batch to continue on our project. So here's a list of future works. First, it is a must for some upgrade in terms of both hardware and software. For example, the limitation on the RF315 can be solved by replacing it with a stronger piece of tech that can provide the same functionality. Second is the visualization of the project. That means this project will have a real prototype that can present better for the audience to understand better. Third, it is possible for this project to establish a connection with company since this project aims to solve the real life problems. Last but not least, this project also holds the potential to be commercialized as real product, and with the futuristic vision and mission, this project has the value and power to change the current traffic light system. So that's all from us. Good for session 1. Thank you.